Alright, quick video, last one, part 3 if you will, of section 5, in how do you find the measure of all 7 angles related to a circle. And so far, ladies and gentlemen, we've talked about 6 of them. Here they are. Central angle where the vertex was on the center. Inscribed and tangent chord where the vertex was on the circle. Tangent, tangent, secant, secant, and secant, tangent. It's where the vertex was outside the circle. So there's only one other place the vertex can be. We've talked about on, we've talked about center, we've talked about outside the circle. The only other place that this bad boy could be is somewhere inside the circle, but it just can't be the center. And that's the last one we're going to talk about. And that angle is called a chord angle. So on your foldable, the last part of it, you need to put this. Where is the vertex? Inside the circle, but it's not the center. Because if the vertex is inside and it's the center, that's called a central angle. We're not talking about that in this short little video. It's inside the circle, but not the center. So, open up the foldable flappy on that flap right there, and let's get one quick example. Chord angle. Let's go! So here's your chord angle, and it looks exactly like this. Again, right there is the vertex. It is in the center. No, sorry. It's in the circle, but it's not the center of the circle. You can see the center of the circle is Y. So it creates this chord angle. Oops, sorry. Here's your definition of chord angle. I'd write it in my foldable flappy if I was you. The vertex is inside, but not the center. And its sides are made up of 2 full chords where they intersect right there in the circle, but not the center. So the question is, what's the measure of this chord angle, like right there? Or maybe what's the measure of this angle right there? Or maybe what's the measure of this angle right there? Or maybe what's the measure of this angle right there? They're all chord angles. Here's one, there's a second one, there's a third one, and there's a fourth one. So, let's do it. Let me give you an example, and you'll see how this works. So let's say we have one arc in this circle Y, where AB, that arc up here, AB, is 70 degrees. Wonderful. And then DC, good old District of Columbia, on circle Y is 90 degrees. So this is 90. So here we go. The question is going to be, what's the measure of angle AEB? That's this one right here. Well, let's see. What if I take half of 70? No. That angle right there is not half of that because it's not, let's see, what is an inscribed angle and tangent chord? So tangent chord angle and inscribed angle is where you take half the measure of the arc. That's not what this one is. It's not an inscribed angle or tangent chord angle. Maybe it's half. Oh, well, here we go. Maybe I take, the difference of these two arcs and I find the measure of this angle. Well, let me kill the suspense and let's do this. So here is the measure of the angle. You get 80. How in the world, again, do you get 80 from, again, this being 70, whoa, and that being 90? Well, let's look at it a second. Oh, I see it. I got it. What if I took these two arcs that this angle right there is facing, and its vertical angle, which they're congruent, vertical, is also facing. So I take those two facing arcs, if you will, and what if I added them together? Let's take the sum of these two arcs. That gives me 160, but wait a minute. My answer is 80. Oh, what if I take and divide that in half? That's right. That gives you your answer of 80. So technically, here is your formula. You take 1/2, ooh, nice, the sum of the two arcs, and that gives you the measure of that chord angle every single time. Let me move this so you can see. I'll make it, whoa, well, that's fine. It doesn't matter. I'll move this over here. I don't know, whatever. So now check this out. Let's see if I can make it a nicer example. Make it 140 and 110. So there we go. So what I'm looking for again is AEB. So it's this angle right there. So angle AEB, according to this arc is 140. This arc is 110. If I took those and added them together, that would give me 250, the sum of those two arcs. But then when I take half of that, oh, check it out, it gives me 125. So there you go, guys. That's exactly how you do it. This is exactly what I'd write into my notes, in my foldable flappy, and this is your formula. To find the measure, well, that's supposed to say chord, sorry. Chord, angle. Yeah, that's definitely right. There we go. So, the measure of the chord angle is half the sum of the measures of the intercepted arcs. Awesome. That is exactly how you do it. Now check this out. Just as a silly another little example. Let me move this over here. I don't know, I'll make it 40. 40 and 110. Lovely. So what happens though if I change the question now and I said, well, let's not find this. Hold on. That's 40. That's 110. Let's not find the measure of this angle. Let's go over and find the measure of this angle. Whoa. Well, if I'm going to find the measure of that angle, guys, here's what it would mean. It would mean I would need then the measure of this arc over here and its vertical angles, opposing arc, right there. I don't have either of those things. But here's what I do have. I do have the measure of this angle right there to be 75 by taking half the sum of the two arcs. And since I know that AEC is a straight angle, oh yeah, that's true. So if this is 75 in here, then all I got to do is take 75 and subtract that away from my straight angle measure of 180 degrees, and that will give me my answer over here, as opposed to not even worrying about finding the measure of that arc and that arc. Now, just truth be told, sometimes you might be able to find the measure of these two arcs. But in this case, you didn't need to, because you know that this is a straight angle, and supplementary angles make it a wonderful answer. Cool. So there you go. I'm rock and rolling. I'm excited to do this in class with you guys. Chord angle, and now we've finally done everything that you need to know in Section 5 to find all 7 angles, all 7 measures of these particular angles, no matter where the vertex is. Whether it's on the circle, whether it's in the circle, but not the center, whether it's the actual center of the circle, and whether the vertex is outside the circle. Awesome. We'll talk to you guys later. Peace.